Good evening, students. Today I am going to discuss how image is formed by spherical lenses. So let us see image formation by lenses using ray diagrams. As you know, this is convex lens. This is focus. It is ray of light coming from object and it is parallel to the principal axis. This is principal axis. So after passing through the lens, it passes through the focus. Again I repeat, if a ray of light is parallel to the principal axis, after passing through the lens, it passes through the principal focus on the other side of the lens. In case of concave lens, is concave lens, it is principal axis, it is principal focus, this is also principal focus, it is ray of light parallel to the principal axis. After passing through the lens, it appears to diverge from the focus in this way. So this is first rule, and now second rule is this is optical center, this is focus, this is also principal focus, this is a ray of light passing through the focus. After passing through the lens, it becomes parallel to the principal axis. So if a ray of light is passing through principal focus, then after passing through the lens on the other side, it becomes parallel to the principal axis. In case of concave lens, this is principal focus, this is optical center, this is also principal focus. It is ray of light incident in the direction of focus. Then after passing through the lens, it becomes parallel to the principal axis. So this is second rule. When a ray of light is coming in the direction of focus, then after passing through the lens, On the other side, it becomes parallel to the principal axis. This is second rule. And third one is it is optical center, it is principal focus, it is also principal focus. This is a ray of light which is passing through optical center. So if a ray of light passes through optical center, it passes without deviation. So it passes straight without any deviation in case of convex lens. The same will happen in case of concave lens also. This is optical center, this is focus, this is also focus. This is ray of light which is passing through optical center. So it passes without any deviation. So this is third rule. So in overall, to draw ray diagram to get the image by spherical lenses, any of the two rays we will use. We will select the two rays out of all these three. So only two rays are required to draw the ray diagrams. Now take a screenshot of it. Now I am going to discuss how image is formed by convex lens for different position of object. So first case is when object is placed at infinity, means far away. So how image is formed, let us see. This is optical center, this is F1, this is 2F1, this is F2, and this is 2F2. You make it very clear that distance between O and F1 is same as distance between O and F2. So F1 and F2 are at equal distances from optical center. So when object is at infinity, so we will draw two rays coming from infinity, supposed to be parallel. One on either side of the principal axis. These are the two rays coming from object which is placed at infinity. So as you know, by applying the rule, this is a ray of light which is parallel to the principal axis. So after passing through the lens, from where does it go? It will pass through the principal focus like this. And for this ray also, it will pass through principal focus at this point. Make arrow on both the side. So at this point, means at F2, the two rays are intersecting. So the position of image will be at focus. So what is the position? Position of image. It is at focus. What about the nature? Nature of image is real and inverted. And what about the size of image? The size of image is very small, so we will write highly diminished. Because this image is point size image, so image is highly diminished. Now second case is object is beyond 2f1. So we will see here. This is optical center. This is f1. This is 2f1. This is f2. And this is 2f2. So object is beyond 2f1 means let object is here. This position is beyond 2f1 because 2f1 is here. So we will draw only two rays. First we will draw a ray parallel to the principal axis. As you know, after passing through the lens, it will pass through the focus like this, and another ray is starting from the object. This is object. AB is object. So draw one more ray which is passing through optical center like this. Don't forget to draw arrow, indicating arrow on each incident ray or refracted ray on both the side of lens. So make arrow. As you can see, these two rays intersect at this point. So drop perpendicular from the principal axis. This is head, it is B dash, it is A dash. So A dash, B dash is image. You can see the image is between F2 and 2F2 in this case. So position of image is between F2 and 2F2. What about the nature? Because the rays are really meeting, really intersecting, so the nature of image is real real and inverted. The image is real and inverted. And what about the size of image? You can see this is object and this is image. The image is smaller than object. So if you find like this, the image is smaller than object, then you can use the term diminished if the image is smaller. So image is diminished in this case. Now third position, when object is placed at 2f1. So let us see. This is principal axis, this is optical center, this is f1, this is f2, this is 2f2, and this is 2f1. Okay. Now object is at 2f1. This is object. So draw one ray parallel to the principal axis. It is parallel, and after passing through the lens, it passes through the focus on the other side. And draw another ray which is passing through optical center like this. This is ray which is passing through optical center. The two rays are meeting at this point, so draw perpendicular at this point. So this is the image and this is object. You can see the size of image is same as the size of object. So what is the position of object? Position means position of image, where image is formed. So position of image is at 2f2. So when object is at 2f1, the image will be at 2f2. What about the nature? Nature of image, it will be real and inverted. Real and inverted. What about the size? Size of image is same as object. Same as object. This is third case, and the next case is when object is between 2f1 and f1. When object is between 2f1 and f1. So let us see. This is optical center, this is f1, this is 2f1, this is f2, this is 2f2. So object is between 2f1 and f1. So we can place object anywhere between f1 and 2f1. So this is object. Draw one ray parallel to the principal axis. According to rule, it will pass through focus like this, and draw another ray passing through optical center. This is the ray which is passing through optical center. So you can see here the two rays intersecting. So draw perpendicular at this point. This is image. So let AB is object. So it is head and it is B dash and it is A dash. A dash B dash is image. You can compare the size of image. As you can see, this is image and this is object. The image is bigger than object. So the image is magnified. So what is the position of image? Position of image is beyond 2f2. This is position, and nature of image is real and inverted. Real and inverted. And what about the size? Because you can see the size of image is bigger than the size of object. So we will use the term magnified. Magnified, or we can also use the term or enlarged. Enlarged. So the image is in this case magnified or enlarged. Now take a screenshot of it. Now this session is completed. We will discuss some more ray diagrams in next video. Thank you, students.